Permutations and combinations. In order to compute the probability of an event, you need to know the number of outcomes in the sample space and the number of outcomes in the event. Sometimes determining the number of outcomes takes some work. Here, there are three different techniques for counting outcomes. Technique number 1, the fundamental counting principle. We use this when there are multiple independent events and each one with their own outcomes, and we want to know how many outcomes there are for all the events together. For example, at a local ice cream shop, there are 5 flavors at a homemade ice cream: vanilla, chocolate, strawberry, cookie dough, and coffee. We can choose to have an ice cream in a dish or in a cone. How many possible ice cream orders are there? All we have to do is to list them out and multiply the flavors, in this case there are 5, and the 2 that are the number of choices that we have in which the ice cream is served. Technique number 2, permutations. We use this when we are counting the number of ways to choose and arrange a given number of objects from a set of objects. For example, in 3 alphabets are to be chosen from A, B, C, D, and E, such that the repetition is not allowed. Then in how many ways can it be done? The number of ways 3 alphabets can be chosen from 5 will be, according to the formula, the factorial of 5 over 5 minus 3 factorial. Therefore, the answer is 60 possible ways.
My name is Marco Telles. I'm going to explain the concept of combination. First of all, it's important to mention that this formula is used when the order of the factors doesn't matter. So, to explain it, I'm going to use an example. We have 9 persons who are waiting for a train, and there are only 5 seats. Imagine that. And we want to know how many possible ways are there to occupy these seats. So we gotta use combination. The order doesn't matter. First of all, N stands for the total of elements, which is 9 because we have 9 persons. And then there's R, which is the number of possible seats, which is 5. Okay? And this is the formula. So we gotta substitute all the possible values. Then we are getting 9 permutation over 5 permutation times 9 minus 5 permutation. And in order to do it faster, we can put it in our calculator. So this is the button for combination. We gotta put the values first. The value of n, 9 combination r, which is 5. So we got a value of 126 possible ways of sitting.
So I'm going to talk about probability. We use probability whenever we're unsure about the outcome of an event, and we can talk about the probabilities of certain outcomes, how likely they are. So the easiest example for understanding probability is when you flip a coin. There are 2 possible outcomes. Those are heads or tails. And in this case, I chose heads. And first the question is, what is the probability of having as a result heads? And we write as the denominator. So as the denominator, we write the number of equally likely possibilities, which is the total of possible responses, and in this case is 2, which are heads or tails. And well, in the numerator I wrote 1 because these are the number of possibilities that meet my condition, because it's 1 of 2, which in this case is heads. So if we make the operation, the result is this 0.5, which if we take as a percentage give us 50%.